Academy, and in today's session we shall discuss about the NEET 2025 Chemistry question paper 8 discussion, and I am very happy to welcome you all to this wonderful session. Yes, let's begin the session. Yes, the question number 46. With increasing bond order, the stability of bond. What he has asked? What he has asked? He has asked with increasing bond order, the stability of bond. What happens to the bond if bond order increases? Let us take an example of nitrogen molecule. Nitrogen molecule consists of nitrogen-nitrogen triple bond, right? And take an example of oxygen. Oxygen is having a bond order 2, and this is a oxygen molecule. And take an example of hydrogen molecule. Hydrogen formed single bond. This is a hydrogen molecule. Comparing to these three bonds, the most stable bond is a triple bond. Hence, with increasing the bond order, this is the bond order of nitrogen molecule is 3, and the bond order of oxygen is 2, and the bond order of hydrogen is 1. And according to the stability, the stability will increases with the stability of bond is increases with increase in the bond order. Hence, the right option is option number 2. So option number 3. Yes. Look at here, question number 47. When a lead storage battery is discharged, lead storage battery is a secondary battery. Lead storage battery is a secondary battery. What happens here? Look at this one. When lead storage battery, I will write the reactions of lead storage battery. This is a lead and lead oxide. Overall reaction I am writing. And here, in the presence of acid, the reaction takes place. And here, this is discharging reaction. This is discharging in forward and charging in reverse. The lead and lead oxide reacts with a concentrated H2SO4, produce 2 PbSO4, means lead sulfate, and releases 2 H2O. Hence, what happens here? During the discharging of battery, there will be a consumption of H2SO4 takes place. Hence, the right option is option number 4. Yes. Next, move to the question number 48. Which of the following is the correct decreasing order of the acidic strength of? Here they have given 4 acids, right? 4 acids they have given, and according to their acidic strength, we have to set them in the increasing order. See here, methanoic acid CH3 HCOOH is a methanoic acid, and ethanoic acid is CH3COOH, and propanoic acid CH3CH2COOH, and he has given butanoic acid CH3CH2CH2COOH. This is butanoic acid. Look at here, there is no electron donating group. There is no electron donating group in the methanoic acid. Hence, there is no electron donating group. Then the acidic strength is more. Hence, the priority comes to this one. The first one is having acidic strength more. And here, the methyl group is the electron donating group present with acetic acid present in acetic acid. Due to this reason, the acidic strength is increases as compared to the methanoic acid. Hence, the order follows 2. And here the number of carbon goes on increasing in the propanoic acid as well as in the butanoic acid. Hence, the strength follows 2, 3 and 4. Hence, the acidic strength of these acids goes, the option number first is the right answer. Okay, next go for the question number 49. A base as defined by Bronsted theory is a substance which can, what happens here? Here, look at this one. A base, according to Bronsted-Lowry theory, an acid is a substance which donate protons, and base is a substance which accept protons, right? So it is a base is a substance which accepts proton. Hence, the right option is option number 4. And move to the question number 50. Which of the following oxidizing reaction of KMnO4 occurs in acidic medium? Look at this one. Which of the following oxidizing reaction of KMnO4 occurs in acidic medium? First reaction he has given, Fe2 plus green is converted into Fe3 plus yellow, right? And iodide converted to iodate, and thiosulfate oxidized to sulfate. Fourth reaction, nitrate is oxidized to nitrate. Manganese salt is oxidized to MnO2. Here they have given 5 redox reactions, and those reactions which occur in the acidic medium we have to find out. See, first reaction I will go with this one. This one is Fe2 plus KMnO4. I will write it as in the ionic form MnO4 minus plus 8H plus gives you Fe3 plus Mn2 plus 4H2O. This is the reaction that takes place in the first one. So this is a green colored iron converted into, this is in a ferrous, and this is ferric is in a yellow color. So the first one is right, and iodide is converted to iodate. They have given iodide ion, that is iodide. I minus is converted to IO3 minus. So this reaction is conducted here. The oxidation takes place in the presence of KMnO4. The oxidation takes place in the presence of KMnO4. But here what happens? Alkaline KMnO4 is used. In this reaction, alkaline KMnO4 is used to convert iodide to iodate. Hence, second one reaction is wrong, and it is not occur in the acidic medium. And go to the third one. Thiosulfate is oxidized to sulfate. Take an example of thiosulfate reaction. This is S2O3 reaction, S2O3 thiosulfate reaction, which is converted into SO4 2 minus, right? So during the conversion of thiosulfate into sulfate, there is again use of alkaline KMnO4. Hence, alkaline KMnO4. Hence, this reaction is also not occur in acidic medium. and nitrite is oxidized to nitrate. Look at this, 5 moles of NO2, this is a nitrite, in the presence of KMNO4. KMNO4 means MnO4 minus plus 6H plus. This will gives you, in acidic medium, this will gives you 5 moles of NO3 minus 5 moles of NO3 minus plus Mn2 plus, this is 2 moles and here 2 moles plus 3H2O is the. So hence by seeing this fourth reaction, it will follows and it is occurs in the acidic medium. Again this one is also not follows because it is also occur in alkaline KMNO4. Alkaline KMNO4. Hence the first and fourth are occurs in the acidic medium. Hence the right option is option number 1. And next move to the question number 51. Pure methane can be produced by, here they have given 4 options, right? 4 options. First one is Wood's reaction. Wood's reaction basically tells about that is production of higher alkanes. This tells about production of higher alkanes. Remember this one. Higher alkanes from primary alkanes or lower alkanes, higher alkanes. So this reaction is not involved and not involved in the production of methane. And next go to the coal-based electrolytic method. During the coal-based electrolysis, what will happen? See here, coal-based electrolysis, CH3, C double bond O, OH, right? And here CH3, C double bond O, OH plus 4 moles of NaOH, 4 moles of NaOH, right? So in this reaction, it utilizes all the sodium and carbon and it will produces 2 moles of Na2CO3 plus 2 moles of H2O plus hydrogen gas along with the formation of higher alkane. Here also no methane is formed, hence this option is also wrong. Next move to the fourth option. Fourth option, reduction with hydrogen. Reduction with hydrogen takes place only in the alkenes. Just take an example of what? This is CH2 double bond, CH2 plus H2 hydrogen in the presence of suitable what catalytic hydrogenation reaction. What will happen? This will also produces higher compounds. Hence option 4 will also not follows, but the only soda lime decarboxylation reaction. In this reaction what happens? The sodium acetate CH3 COONA, so sodium salt of carboxylic acid is taken and is reacted with NaOH and CaO, NaOH and CaO. This is called as soda lime. And what will happen? Here this reaction, here elimination of Na2CO3 takes place and it will forms CH4. Hence the third option is the right option. And next move to the 52nd question. 52nd question, and this question, matter consists of, see, Dalton proposed that option number 1, matter consists of atom which is divisible. Are you agree with this one? Highly impossible, because matter consists of atom according to Dalton which is indivisible. That has been explained in point number 2. Matter consists of atom which is indivisible. Hence option number 2 is right. And Chemical reactions involve reorganization of atoms. Exactly. If there is a chemical reaction is going to be taking place, then there will be a reorganization of atoms or rearrangement of atoms takes place. Due to that reason, second is also right. Hence, second and third are right answers. That is option number 4. So we have to mark it as option number 4 is the right answer. Next, move to the question number 53. Yes, here they have given assertion treatment of 1,3-dichloropropane on reaction with alcoholic KOH gives allenes. Right? See here. What happens? Look at the reaction assertion. What happens here? CH3 not, that is 1 comma 3 means Cl CH2 CH and H CH2 means again, okay, I will write it as CH2 and Cl. What will happens again here? If we use KOH, dehydrohalogenation takes place. In first step, if the dehydrogenation takes place, it will forms CH2 double bond CH, then CH2 Cl. Again, if you react with alcoholic KOH, right? Alcoholic KOH, what will happen? Again, there will be elimination of dehydrohalogenation takes place. Dehydrohalogenation means elimination of KCl and H2O takes place due to the nucleophilic elimination reaction. Point number reason, it is a nucleophilic reaction, right? So nucleophilic elimination reaction. So point number 2, look at this one, CH2 double bond C double bond CH2. This is called as an allene. Right? So from the first point, it is what? The treatment of 1 comma 3 dichloropropane on reaction with alcoholic KOH gives allene. Right answer. Then it is nucleophilic elimination reaction. Exactly correct, because there will be elimination of OH means Cl along with OH hydrogen. So this is what? Nucleophilic elimination reaction. Hence both assertion and reason are correct, and reason is the correct explanation of assertion. Let's go move to the point number 1, means option 1 is the right answer. Next, which of the following molecule has a trigonal planar geometry? Which of the following molecule has the trigonal planar geometry? Look at this one. Here I will write the molecule number 1, BF3, right? BF3 is the molecule which is having the shape F, B and F, and each fluorine has a S. And number 2, NH3 and along with this option number 3 also I will write, that is PCl3. And the next option number 4, that is IF3. This is I will draw this structure here. Here lone pair electrons, and here F present. F and F. Here also the lone pair of electrons present at the corner. Hence the structure is this is T shape. The structure of IF3 is T shape, and because the angle is 90 degree, and the structure of this one is even after being the sp3 hybridized molecules, their angle has to be 109 degree 5 minutes due to the bond pair and lone pair electrons, and lone pair electrons, their angle is decreased to 107 degree in NH3 and 103 degree in PCl3. Hence these two shows the structure of, that is called as a square pyramidal, and this one is having the structure, that is called as a trigonal planar. This one is having the structure trigonal planar. Hence BF3 is having trigonal planar structure. Hence the right option is option number 1. Next, the elements with 0 electron affinity are. The elements with 0 electron affinity are. See here, boron, that is 2p1 and 2p2, and beryllium and helium 2s2 and 1s2, and configuration I am telling, and lithium and sodium are, this is 2s1 and this is 3s1, and this one is fluorine and chlorine 2p5 and this is 3p5. Look at this, all the configurations. Here no unpaired electrons at all in its outermost orbitals. If there is no unpaired electrons in the outer orbitals, then the electron affinity of that particular element will be 0. And comparing to, look at here one unpaired electron, here 2 unpaired electrons, and here 1 unpaired, and here 1 unpaired, here 1 unpaired, and here 1 unpaired electron is present in 2p5 and 3p5 electrons. Hence these shows the electron positive or negative electron affinity at their extent because of the number of electrons present in their outermost orbital, but there is no outermost electrons in the outermost orbital. Hence the beryllium and helium are follows the rule. Hence the right option is option number 2. Go to the next question. The complex PT, PY, NH3, Br, Cl, right? This is a geometrical isomer, right? Geometrical isomer, and isomer of type MXLAB type, right? MXLAB type, and this MXLAB type of geometrical isomer exhibit only 3 type of isomers, out of which 2 cis isomers and 1 trans isomer. 2 cis isomers and 1 trans isomers. Hence total number of isomers exhibited by PT-PY, NH3, Br, Cl is nothing but 3 isomers. Hence the right option is option number 1. And look at this IUPAC nomenclature of the compound. Now this is a functional group, and give the priority towards this one, and start to numbering from this side 1, 2, 3, 4, 5, 6. So here what they have given, methyl group is attached to fifth, therefore 5 methyl, then next 3 hexanamine, hex means 6 carbon are there, hex, and hex is because of this is alkane, and amine means amine is in 3rd position, therefore 5 methyl 3 hexanamine. The right option is option number 2. Let us move to the question number 58. 58 statement they have given. The compounds containing CHO groups are easily oxidized to corresponding carboxylic acids. Obviously, if CHO group in a compound RCHO is there, RCHO is there with a suitable oxidizing agent, what happens? It will converted into RCOOH. Yes. Thank you, Vijay Puranik Mutt. I need your support. Yes. Okay. And next, RCHO, KMNO4, in the presence of suitable oxidizing agent, it will produce carboxylic acids. Exactly right. And next, statement 1 is right. Next, statement number 2, carboxylic acid can be reduced to alcohol by treating with lithium aluminum hydride. Yes, RCOOH can be converted with LiAlH4. This will be RCH2OH alcohols. Hence the second statement is also right. Therefore, both the statement 1 and statement 2 are correct. So, option number 1 is the right. Next, move to the question number 59. The inert pair effect is most prominent in. Look at here. What is inert pair effect? Inert pair effect is nothing but it is the non-use of that is electrons present in the s orbital of larger elements. Comparing to this one is carbon, lead and germanium and silicon. Out of these 4 elements, the lead is having a larger size, and in this larger sized atom, what will happen? There will be a s orbitals are not used for bonding purpose. Hence, it is called as inert pair effect. Hence, it shows more inert pair effect as compared to other 3 elements. Hence, the right option is option number 2. Next, a solution containing components A and B follows Raoult law when. Look at here. This is, what is this? Here, first option is option A. AB attraction force is greater than the AA and BB attraction. This is not right, because according to Raoult law we have to explain the things. Hence, the solute-solvent attraction force is greater than the solute-solute and solvent-solvent interaction. He has told this is wrong about the Raoult law explanation, and solute-solvent attraction force is less than the solute-solute and solvent-solvent force of attraction. Hence, this is also wrong for the Raoult's law explanation, and solute-solvent attraction force remains as that of solute-solute and solvent-solvent interactions. Hence, the third option is the right option according to the Raoult law. Hence, the third option is the right answer for the question number 60. Let's move to the 61 question. Here they have asked the carbon, oxygen and carbon bond angle in ether is about, that is nothing but option number 3, that is 110 degree. The direct option, you go with option number 3. And next, how many elements are there in the 6th period of periodic table? Let's calculate. S orbital 2 elements, and P orbitals 6 elements, D orbitals 10 elements, and F orbitals 14 elements. Combined together, 2 plus 6, 8, 8 plus 10, 18, 18 plus 14, that is equal to 32 elements. That is option number 4. Option number 4 is the right answer for 62nd question. And move to the question number 63. The mass and volume of a substance are the extensive properties and are proportional to each other. When the density is constant, D is equal to constant, and the mass and volume are proportional to each other. When density is constant, mass and volume are proportional to each other. Hence, mass and volume are individually, they are extensive properties, right? And next, the ratio of mass of sample to its volume is an intensive property. The ratio of mass of sample to its volume is intensive property. Look at this one. The ratio of mass and volume is nothing but density. Mass by volume is equal to density. Density is an intensive property. Hence, they are individually correct. They are individually correct. Both statement, assertion and reason are individually correct. But the assertion is not correct explanation of, the reason is not correct explanation of assertion. Hence, the right option is option number 2. Next, move to the question number 64. The orientation of an atomic orbital, the orientation of atomic orbital is governed by, simple, that is none other than magnetic quantum number, right? The spin quantum number tells about the spinning, filling of electrons by spinning, and principal quantum number tells about, tells about spinning of electrons, spin of electrons during the filling, and then principal quantum number tells about yaudur bage, it tells about Subhas Narasangi, thank you so much. And principal quantum number tells about the orbital and filling up of electrons in the shells. And azimuthal quantum numbers tells about the shape of the orbitals. But orientation means the direction of orbitals. Look at here, the direction of orbitals. If you take the px, py, pz orbitals, px, py, pz orbitals, I will explain with the help of diagrams. Px orbital is like this, and py orbital, 1 minute, px orbital, the shape of the orbital, this is px and this is py, and this is pz orbital. So this is the orientation. Yes, the orientation means the direction of orbital is governed with the help of magnetic quantum number. So the right option is option number 2 for 64 question. Let's move to the question number 65. Statement 1. Statement 1 is in a Sandmeyer reaction, nucleophile like Cl minus, Br minus and Cn minus are introduced in benzene ring in the presence of Cu, means copper 1 ion. Look at here, this is a benzene disonium chloride. This is benzene disonium chloride, right? N triple bond N triple bond N, Cl minus, here plus, right? And next move to the yes, here we use HCl acid, here HBr acid, and here that is CuCN directly, and here what happens, copper 1 Cu2 Cl2, copper 1 chloride is used, here copper 1 bromide Cu2 Br2 used, here CuCN, right, is used, and it will forms chlorobenzene, this is bromobenzene, and this is cyanobenzene or benzene nitrile, right? Like this it will forms, right? So now in this particular reaction, the statement 1 is right, and statement 2, in Gattermann reaction, the nucleophile is introduced in the benzene ring in the presence of copper powder and HCl, exactly correct. Here they will use, in Gattermann reaction, they will use Cu powder bar HCl. This will directly produces this will produces chlorobenzene. Hence, statement 2 is also right. Therefore, the right option is both statement 1 and statement 2 are correct. That is option number 1. 65, option number 1 is the right answer. Next, move to the question number 66. EDTA, previously also asked and now also they have directly asked. So, no problem at all. EDTA, I will again draw the structure of EDTA, CH2, N, CH2 and N, CH2 C double bond O minus, CH2 C double bond O minus, and again here CH2 C double bond O minus, CH2 C double bond O minus. Look at this one. Here again 4 acetate ions and 2 nitrogen ions combined together. How many ligands, how many donor atoms are here? 6 donor atoms. Hence, if there is a presence of 6 donor atoms, then it is a hexadentate ligand. Now move to the question, option number. Here we have to mark the option number 4 as a right answer for 66 question. Let's move to the next question. Addition of solution of oxalate to aqueous solution of mixture of Ba2 plus Sr2 plus and Ca2 plus. Simple. The oxalate reacts with all these ions and forms the all 3 ions oxalates. All 3 ions oxalate. Hence, option number 4 is right. And next, the rate constant of a forward reaction is Kf. I will this one. The rate constant for forward and backward reaction of hydrolysis of ester. Ester is nothing but ethyl acetate are 1.1 into 10 to the power minus 2 and 1.5 into 10 to the power minus 3 per minute respectively. Find out the equilibrium constant. We have to find out Kc. So, Kf is equal to what they have given. Kf is forward reaction 1.1 into 10 to the power minus 2 and Kb is nothing but backward reaction, rate constant of backward reaction, that is 1.5 into 10 to the power minus 3. And what will be the Kc? Kc we are going to find out. So, interchange the position of the 10 powers. Kf by Kb is equal to 1.1 into 10 to the power 3 divided by 1.5 into 10 to the power 2, right? This will becomes 1100 and this will becomes 150. So, after this one, this will be 150 and by solving this one, 110 by 15 sevens are 105, again 50 will remains, 15 threes are, keep a point, 15 threes are 45, again 5 will be the denominator, that is quotient, and again make it 53, so 45, again 5. So, the right option is 7.33 is the right answer for the question number 68. And let's move. Which of the following arrangements does not give the correct picture of the trends indicated against it? Here they have given the decreasing order of the halogen atoms, and in front of them they have given their trends where they are. So, look at this one. The oxidizing power, we have to find out which arrangement is not give the correct picture. So, oxidizing power, fluorine is greater than, chlorine is greater than, bromine is greater than iodine. In the periodic table, fluorine is having a most powerful oxidizing capacity, hence it acts as a oxidizing agent, and least one is iodine, and chlorine and bromine comes in between that one, hence first one is right. And the electron gain enthalpy See here, electron gain enthalpy, fluorine, chlorine and bromine and iodine. Look at the sequence. Here fluorine is having a smaller size and iodine having a bigger size as compared to the fluorine. Hence electron gain enthalpy capacity is decreases. Here increases from, means least one is electron gain enthalpy, least one is having that is fluorine and most one is having iodine because of the size of the atom. Hence second one is not follows and second one is not correctly matched. And third one is the bond dissociation energy. Bond dissociation energy, fluorine, chlorine, bromine, iodine is having. See here, these this one is also bond dissociation energy as comparing to this one. This one is the third one is also wrong due to their size. Hence bond dissociation energy is least in most in iodine and least in fluorine, but they are having most in fluorine and least in iodine. Hence this one is also wrong. And electronegativity, the most electronegative atom in the periodic table is halogen in the halogen atom is fluorine, and the least electronegative atom in the periodic table is iodine. Hence this one is follows the rule and the trend against it is correctly matched. And the melting point, what reciprocal? This one because for the purpose of simplification I have taken it as reciprocal, otherwise there is not an issue. If you want you can directly calculate it, again you will get the 7.33 answer, right? Okay, no problem, not an issue. But if you not taking the reciprocal also for 68 question, so no problem, you can directly solve it. Again also you will get 7.33 answer. After solving also, again this 3 goes to the numerator. If this 3 is moved to the numerator, again it will become positive 3 only. Hence it can be easily solved. And here the next question, fifth one is the melting point. Fluorine is having least melting point as compared to the iodine. Hence the order is again follows. Hence given trend 1, trend 4, trend 5 are correctly matched, and trend 2 and trend 3 are not matched with their arrangements. Hence the right option is third one, that is 2 and 3. And which reaction is used for detecting the presence of carbonyl group? Look at this one. If reaction with hydrazine, it will produces hydrozones. This will produces carbonyl group. Any carbonyl group you may take. I will take R, C double bond O, H, and when it reacts with NH2, this is a hydrogen. This will produces R, C, H double bond N, NH2. This is hydrogen, and this method is also used. And the reaction with phenyl hydrogen, instead of hydrogen I will take the phenyl hydrogen, that is R, C double bond O, H plus NH2, NH. This is phenyl hydrogen, and after reacting that it will get R, C double bond OH, N, NH. So this is what it will produces. This is phenyl hydrazone it will be obtained. And next this one, reaction with hydroxylamine. Hydroxylamine, see R, C double bond O, H. This will on reaction with NH2OH. This is hydroxylamine. This will directly produces oxime. This will produces directly oxime, RCH double bond O, NOH. This is hydroxylamine. Hence, these three are used in the particular reactions. Therefore, the right option is all of the above. All of the above. Yes, dear students, what they have given. Channamma Hiremat. Thank you so much, ma. Thank you. We need your support too. And ನಾನು ಇಂಟರ್ನ್ಯಾಷನಲ್ ಏರ್ಪೋರ್ಟ್ದಾಗ ಕೆಲಸ ಮಾಡ್ತೀನಿ ಸರ್, ಅದು ನಿಮ್ಮ ಕ್ಲಾಸ್ ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ವೆರಿ ಹ್ಯಾಪಿ ಟು ಹಿಯರ್ ಯು ದ್ಯಾಟ್. ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್ ಅಮ್ಮ ಚೆನ್ನಮ್ಮ. ಆ್ಯಂಡ್ ಬೆಂಗಳೂರದಾಗ ಬನ್ನಿ ಬೆಂಗಳೂರು ಬಂದಾಗ ಬನ್ನಿ ಸರ್. ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್ ಅಮ್ಮ. 100% ಡೆಫಿನೆಟ್ಲಿ ಐ ವಿಲ್ ಕಮ್ ಟು ಮೀಟ್ ಯು ವೆನ್ ಐ ಕೇಮ್ ಟು ಬೆಂಗಳೂರು. ಆ್ಯಂಡ್ ನೌ reduction of glucose by HI suggests that simply if you reduce the glucose with the help of hydrogen iodide, it will gives you long chained hydrocarbon, that is 6 carbon atoms are arranged in straight line, that is option number 4. There is nothing in the reaction. So next, if we go to the question number 72, here the radius of third Bohr orbit of hydrogen atom is R3 and the radius of fourth Bohr orbital is R4. Then what will be the ratio of these? Simply I will solve this one. Rn, I will use the formula Bohr's radius. Rn is equal to 52.9 n square divided by z. Angstrom unit is the formula to use to calculate the Bohr's radius. And now I will use Rn. Rn is nothing but, look at here, they have given clearly mentioned Rn means n is equal to 3 and 52.9 by 52.9 into n square is 3 square. Z is hydrogen atom they have taken, for that reason 1 angstrom unit, and R4 is equal to 52.9 into 4 by 1. So if we take the ratio of these two, then this will be cancels 4 square, and what will be the answer? R3 divided by R4, 3 square is equal to 3 square means 9 divided by 4 square means 16, and taking the cross multiplication, we will get R4 is equal to 16 by 9 R3. The right option is option number 2 for this one, right? Yes, okay. Assertion: the order with respect to reactant B may be negative, and reason: the order with respect to a reactant may be negative. In some cases, the rate of reaction decreases as the concentration of the reactant increases. See this option. Look at this one. The order with respect to the reactant is negative 100%. There is no doubt about it, because based on the availability. And then in some cases, the rate of reaction decreases as the concentration of the reactant increases. Both here they have given, both the assertion and reason are correct, and R is the correct explanation of assertion. Hence it follows option number 1. And move statement 1. Phenols are weakly acidic. Exactly right. Phenols are weakly acidic. Therefore they are freely soluble in NaOH. This statement is also agreeable. But look at NaOH solution, and are weaker acid than alcohol. This is wrong, because phenol is more acidic than alcohol and water. Hence statement 1 is right and statement 2 is incorrect. Therefore the right option is statement 3. The right option is 3. Okay. In which of the following pairs of ions are colored in aqueous? See here, option number 1, scandium is D0 electronic system, D naught configuration, and titanium is D1 configuration. Hence, one is colored, one scandium is not colored, and that is titanium is due to the presence of unpaired electron. This is colored. And statement 2, scandium is again Sc+3 D naught configuration, and cobalt 2 plus. Cobalt 2 plus is in D8 configuration, D8. So D8 is nothing but, sorry, D7. Cobalt is in D7 configuration. D7 is nothing but there are 2 unpaired electrons. Hence, this is also, one is not colored and one is colored. And here, third option, nickel 2 plus. Nickel 2 plus is colored due to the presence of 2 unpaired electrons. This is colored due to 2 unpaired electrons. Cu2 plus, I will write here, this is D8 configuration, D8 configuration, 2 unpaired electrons, hence it is colored. And Cu plus is the D10 configuration. Cu plus is D10 configuration, due to the absence of unpaired electron, it is not colored. And move to the question number, option number 4. Option number 4, that is Ni2 plus. Ni2 plus, this is D8 configuration and having 2 unpaired electrons, and Ti3 plus is in D1 configuration, and this one is D1 configuration, 1 unpaired electrons, hence both are colored compounds. Hence the colored, both are colored in aqueous solution. Hence option number 4 is the right answer. Next, the stability of 76 question, the stability of CaOH twice in water is, sorry, the solubility of CaOH twice means calcium hydroxide in water. So the solubility product of water is, they have given. See here, this is CaOH twice. CaOH twice. CaOH twice is a type of compound, that is AB2 type of compound. This is AB2 type compound, remember. So in this AB2 type, the solubility product Ksp is equal to what it is, 4s cube. The solubility product of the compound is Ks cube. Now they have given the solubility product as 5.5 into 10 to the power minus 6 is equal to 4s cube. And now s cube is equal to 5.5 divided by 4 into 10 to the power minus 6. And now taking the cube root of this one, s is equal to cube root of 5.5 divided by 4 raised to 1 by 3 into 10 to the power minus 6 by 3. This will becomes 1.1 into 10 to the power minus 2. The right option is 1.11 into 10 to the power minus 2. That is option number 2 is the right answer for the 76th question. Next, move to the question number 77. Which of the following compound will show positive silver mirror test? Silver mirror test is nothing but identification of the carbonyl carbon along with hydrogen. Look at here, where in the given compound, if there is a C double bond OH group is combinedly present, then it will easily reduces the silver ammonical nitrate solution and gives positive silver mirror test. That is option number 1 and option number 2 both are having CHO in their structure. Hence those two compound together reduces the Tollon reagent and forms the silver mirror test positive, and hence the right option is option number 4, right? Okay. And next, activation energy of the reaction is, see here, first one is option number 1, the energy released during the reaction, the energy evolved when the activated complex is formed, minimum amount of energy needed to overcome the potential barrier, and the energy needed to form 1 mole of the product. See here, just I will explain with the help of a diagram. Yes, this is a complex. This is a potential barrier energy curve diagram. Look at here, hydrogen H2 plus I2 combined together form here. This is activated complex is formed HH I bond I and here. So this is in the form of, look at this, I and the bond is like this, right? So here what is happening, here the dissociation of old bond is taking place between the hydrogen and iodine, and formation of the new bond is taking place between the hydrogen and iodine, and this will forms 2HI molecule at the final, and here the minimum amount of energy needed to overcome from the potential barrier, that energy is called as activation energy. Hence the right option is option number 3. And next, in which of the following compounds the oxidation number of iodine is a fraction? Simple. Look at this one, just X is equal to 7 for option number 1, and I will calculate and show you. That is X minus 7 is equal to 1, and X is equal to 7 for option number 1, and option number 2, and option number 2 they have given, that is 3X is equal to minus 1, X is equal to minus 1 by 3, and option number 3, this is X plus X minus 5 is equal to 0, and X is equal to, X minus, this X is equal to 5, and this one is 4, and for X minus 3 is equal to 0, and X is equal to 3. And among these, the fractional oxidation number is goes to option number 2. Hence, right option is option number 2. And diazonium salt is obtained when aniline is reacts with simple diazonium salt. First, we react this one NaNO2 plus H2O. What it will gives you? HNO2 plus HNO2 plus NaCl. Again take this and react this with aniline. This is NH2 plus HNO2, HON double bond O plus, here they will use excess HCl, right? Why I have written this in a separate form? Because we have to extract the required components from this one. Look at this, 1H, 2H, 3H, 4H and 2O, that is minus H2O is eliminated, and this N is bonds with this N, this bond is bonds with this N, N triple bond N, then Cl minus, and this will produce a Cl minus, here plus. So the right option is NaNO2. Here they have told option number 1 as quad NaOH, it is not used, and SnCl2 at 10 degrees Celsius, it is also not used. NO2 N2O means nitrous oxide, this is also not used, and the right option is option number 2. Hence the diazonium salt is obtained when aniline reacts with that is NaNO2 and HCl at 0 to 5 degrees Celsius. Next, 81st question, the value of spin only magnetic moment for one of the following configuration is 2.82. The correct one is, they have told, this is D5. I will write here T2G configuration for option number 1 and option number 2, option number 3 and option number 4. Look at this one, T2G and EG. Here D5, all the 5 electrons are present here. T2G 5 and EG 0, and D3, all the 3 electrons present in the T2G and there is no electrons present in the EG splitting. and D4 in weak ligand, what will happen here? All the 4 electrons are present in D3 by pairing, and here, 1 minute, here 3 and here 1 configuration, and D4 for strong ligand, this all 4 electrons present here in, and these 4 electrons are present in the form of D3, means here 3 orbitals present, D1, DXY, DYZ, DXZ are here, and in DXY it is paired, and DYZ and DXZ it is unpaired, hence here n is equal to 2, here n is equal to 2, hence the bond order, that is mu is equal to, bond order not, this is a spin only magnetic moment, mu is equal to, n of n plus 2 Bohr magneton Bm, that is 2 of 2 plus 2, that is equal to 2 into 4, that will be 2.82. This is 8, root 8 is nothing but 2.82 Bohr magneton. Hence the last option, D4 in strong field ligand, D4 in strong ligand fields configuration shows the spin only magnetic moment 2.82. Therefore, the right option is fourth one. And next, consider the reaction N2 plus 3H2 gives 2NH3. It is a gaseous reaction carried out at a constant temperature and pressure. If delta H and delta U are the enthalpy and internal energy changes for the reaction, which of the following expresses the true? Look at this one. Option number 1 is given, that is delta H is greater than delta U. Option 2, delta H is less than delta U. Option 3, delta H is equal to delta U. And option 4, delta H equal to 0 they have given. But the formula is delta H is equal to delta U minus delta Ng RT plus delta Ng RT, right? Okay, delta Ng RT. Now, in product size 2 moles and in reactant side minus 3 minus 1, that is equal to 2 minus 4, that is equal to delta Ng value is equal to 2 minus 2, right? Substitute in the equation, delta H is equal to delta U minus 2 RT, Ng value after substituting 2 RT. Now delta U is equal to delta H plus 2 RT. Therefore, delta U is greater than delta H. It shows delta H is less than delta U. Delta H is less than delta U. Option number 2 is the right answer for the question number 82. Now, assertion, phenol is more reactive than benzene towards the electrophilic substitution reaction. 100% because of the presence of phenol is containing OH group. This OH group is electron donating group. Hence, comparing to benzene is not having any reactive group on its head. Hence, it is more reactive towards electrophilic substitution reaction. Right? Therefore, first assertion is follows. Next, in the case of phenol, the intermediate carbocation is more resonance stabilized. See here, if there is a new electrophile is attached in the position where, in the ortho position, just I am taking an example, if electrophile is attacked with the help of this bond OH, and here any electrophile is here the carbocation is generated, right? And this carbocation is more stabilized because here OH is an electron donating group, and this OH directly donate the electron and stabilize the yes. Thank you, Channamma. Not an issue. Again, it is our duty to give you the questions. Okay, and here this carbocation is easily stabilized with the help of the OH group which is present on the functional group which is present on the head of this benzene ring. That's what second one is also right. Therefore, if both assertion and reason are correct, and reason is the correct explanation of assertion, hence the right option is option number 1. Next, match the column 1 with column 2. See this reaction, what will happen? This is a completely free radical mechanism, because question number means in the option number A, they have given means column 1, they have given in a first reaction C2H6 in the presence of sunlight reacts with Cl2 gives C2H5Cl, means it is a free radical mechanism, because here they have used ultraviolet light. This in this reaction only they will use ultraviolet light, hence it directly matches with this directly matches with A matches with Q. And next, this is C6H5NH2 reacts with NaNO2 plus HCl, means NaNO2 plus HCl in the presence of copper 1 chloride. This is nothing but this is Sandmeyer reaction, hence B matches with S. And next, what it is? C. Here halogen exchange takes place between the methyl chloride and sodium iodide. What will happen? The iodide joins to methyl ion and chlorine joins with sodium ion, and this will forms NaCl and CS3I. This is a Finkelstein reaction, hence P follows C, and the last one is Schwarz reaction, this is D. Again here also halogen exchange takes place, the most reactive fluoride ion. So AQ, BS, CP, Dr, hence the right option is option number 1. And next, the vapor pressure of water at 20 degrees Celsius is 17.5 mmHg if 18 gram of glucose is added to 178.2 gram of water at 20 degrees Celsius. The vapor pressure of the resulting solution will be simple. This is a relative lowering of vapor pressure question, and they have directly used here RLVP. RLVP is equal to P naught minus P divided by P naught is equal to W2 divided by M2 into M1 divided by W1. What we have to do? See here, I will take P 1 minus P divided by P naught is equal to W2 they have directly given, that is 18 gram of glucose, and 18 gram of glucose molar mass 180, and next M2 and then M1 is water, molar mass of water is given, and W1 is the 178.2 gram. So after simplification it will be 18 ones 18 tens, and then S 1 minus P divided by P naught value is already they have given. There is no problem to mention it, that is 17.5 they have given, and here also 17.5 is equal to, this one is 18 divided by 1782, and now bringing that to that side and simplification, this much I have given, and after simplification I hope you will solve and get the answer. This much is I have given, and take it as one more thing I will give you, that is 1 minus P is equal to 18 into 17.5 divided by 1782. You will solve this one, you will definitely get an answer of that is 17.325 mmHg. They have given here 15.750 and 16.5 and 17.5 type they have given, but the right option is after solving you will get option number 1 as the correct answer. And next, move to the question number 86. During the experiment to calculate the heat of neutralization of strong acid and base concentration, temperature should be recorded till. Any reaction where the strong acid and base reacts together to form salt and water. During this reaction, there is a release of heat takes place because of the strong acid is reacting with the base. Hence, the temperature is recorded till the constant temperature is achieved. That is option number 1. And next, 87 question. In a steam distillation, the vapor pressure of volatile organic compound is, see here, the atmospheric pressure is equal to ATMP. Atmospheric pressure is equal to the sum of organic compound, vapor pressure of organic compound plus water, right? Organic compound plus water. Atmospheric pressure is always equal to the sum of organic compound, means solute and solvent. And here what they have asked, what will be the, means steam distillation vapor pressure of the volatile organic compound, they have asked. Only if we consider the organic compound, it is very less than the atmospheric pressure. Hence, the vapor pressure of volatile compound is less than the atmospheric pressure. Hence, the right option is option number 3. And move to the question number 88. A solution containing AS3 plus CD2 plus Ni2 plus and Zn2 plus is made alkaline with dilute NH4OH treated with H2S. The precipitate obtained will be consists of, they are told. In option number 1, they have given AS2S3 plus CDS. In option number 2, they have given CDS, NIS and ZNS, means zinc, cadmium sulfide, nickel sulfide and zinc sulfide. And option number 3, they have given nickel sulfide and zinc sulfide. See here, in a solution, all the 4 ions are containing. Hence, in the and is made alkaline with dilute NH4OH and treated with H2S, then what will happen? Again, they will form the ions and they will form sulfides of all the ions. Hence, the right option is option number 4. Yes, the correct stability, the correct order of basicity of the following compounds. This is alkylamine and this is arylamine and this is substituted arylamine. Among these 3, alkylamine is containing electron donating group, hence the basicity increases as compared to the aromatic amine. And this one is, means option C is more basic as compared to the simply basic aromatic amine. Therefore, C is more basic than A. C is more basic than A because it is not containing any such type of substituent group. But here it is containing substituent group. It is electron withdrawing group. Electron withdrawing group. What happens if electron withdrawing group is present in the para position? Definitely it will increases the acidic strength. Hence, which is least basic as compared to the NS3. So the aromatic amine. Hence, that is B is the right option. Therefore, C is greater than B is greater than C is greater than A greater than B, and option 3 is the right answer. And last one is, here they have given matching the compounds. Look at here, ClF3, PCl5, IF3 and CCl4. CCl4 is having a tetrahedral structure and that is PCl5 is having a square, PCl5 is having a square pyramidal and IF5 is having a trigonal bipyramidal and ClF3 is T-shaped. And A combines with P and B matches with S, B matches with S, C matches with R and D matches with Q. Hence, the right option is 1. Therefore, among these, we have solved till the question number 90. And thank you, my dear children, for watching this one. And I request you, all of you have understood the things whatever I have given, and the hearty request is please like, share and subscribe and help us to grow more. This is our heartiest request to you. Thank you one and all.